Good afternoon and welcome to your science review with Mr. Blades. Today we're going to be working on an example using acceleration, distance, and velocity that I went through in my class and I want the rest of you to be able to see. We're going to use an equation that's a little bit different than what we've seen in the past, but it works and is very useful in certain situations. So the example that we have right now is a plane starts off with a velocity of 21 meters per second, accelerates at a constant rate of 3 meters per second for a space of 535 meters. Now, what we want to know is how fast is the plane moving at the end of the runway and how long does it take to get there. All right, so we're going to write down our new equation. VF squared equals VI squared plus 2AD, where VF is our final velocity, VI is our initial velocity, A is our acceleration, and D is our distance. All right, now as you can see, we know all of this stuff except for VF. That leaves us with one unknown, which means we can solve our equation. So we have VF squared equals 21 squared plus 2 times 3 times 535. Now if we punch this into our calculator, we end up with 3651 equals velocity final squared. Now, if I take the square root of both sides, we end up with final velocity equals 60.42 meters per second. Okay? All right. Now, I'm going to erase all this and we're going to find out how long it took us to get here. Now, as you can see, we've updated our drawing to include the final velocity that we calculated in the last part. And now we're going to use that to calculate how long it took our plane to accelerate from 21 meters per second to 60.42 meters per second. Now, our equation that relates these three things is usually in the form delta V over delta T equals acceleration. Now, I need to get T all by himself so that I can solve for T in this case. So what we're going to do is we're going to start off by multiplying both sides by delta T. That gets rid of T on the right side. Now, I want to move acceleration from the left side to the right side by dividing both sides by A. And that leaves us with delta T is equal to delta V over A. Now, if we use our expression for delta V, V2 minus V1, we can rewrite this equation one last time into a form that we can use. So, let's plug in our numbers. 60.42 minus 21 divided by 3. Okay? And when we punch that number in, we end up with 39.42 divided by 3, which is equal to 13.14 seconds. And there we have solved for the final velocity of our plane at the end of the runway and how long it took the plane to get to the end of the runway. I hope this was helpful. We'll see you in class.